All right, so we're going to start dealing with polynomials and monomials. Shh, guys. All right, so section 5.1 is on monomials. So monomials are just one term. There's no you don't have the term added to another term and so on. It's just all together. So it's an expression that's a number, a variable, or the product of a number in more than one or more variables. Monomials do not contain variables in the denominator, variables with negative exponents, or variables under radicals. So an example of a monomial would be something like 2x cubed, right? Or 1/2 xy to the third. You could have like square roots of, like square root of 35, x, y, z. Let's just do x, y, z like that. But things that you would not be able to have would be things like square root of x. So you can have the square root of a number, but you can't have the square root of a variable. You can't have like 1 over x. You can't have x squared minus 3. That would be like the sum or difference of terms. So just one term altogether. Michael, you with me? So things like that. And you can't have like x to the negative 2. That would not be a monomial either. Okay. So it says constants are monomials with no variables. Coefficients are the numerical factors of the number out front. And then the degree is the sum of the exponents of the variables. Okay, so if I have something like x to the 6th, the degree is going to be the highest exponent, or the sum of the exponents. So in this case, our exponent is 6. Okay, so we're going to talk about the degree, and our degree is 6. So the next one, I don't have any x value, right? So if I was going to rewrite this, it would be 14, and it'd actually be x to the 0. Okay, so we'll talk about a 0 power. 0 power is actually 1. Like x to the 0 is the same as 1. So this degree then is 0. There's no x term. All right, so this one, these have a cubed and b to the 6th. So we had 3 and we had 6, so we're going to add those together. So the degree of this monomial is going to be 9. So what's the degree of the next one? 10. And what's the degree of the last one? All right, so this is different than when we talk about polynomials. So when I talk about a polynomial, so if I had like x to the 5th minus 4x cubed plus 2x minus 7. Okay, look at each individual monomial. We'd have a degree of 5, a degree of 3, a degree of 1, and a degree of 0. We don't add all of them together, okay? So our exponent, our highest exponent then would be 5. So the degree of a polynomial would be 5. It's just the highest one. So it's the highest degree of each individual monomial. Okay. All right. So this first part's going to be pretty much review. It does get a lot harder in this section, so make sure you guys are paying attention. So if I have something like 4 to the 7th, this whole thing is called a power. Did I like to where I was before? Yeah, that one. Okay. So the whole 4 to the 7 is the power. The 4 part is called the base, and the 7 part is called the exponent. Do you guys remember that? So even I will mess that up. I'll say 4 to the power of 7, but I should really say 4 to the exponent of 7 or something like that. Okay. So the 4 is called the base, and the 7 is called the exponent. And when we write it out 4 times 4 times 4 times 4, etc., that's called expanded form. Okay, so it's important to recognize what is being raised to a power. So if I have negative 2x to the 4th, like this first one, the x part is the only thing that's being raised to the 4th. Do you guys all see that? Okay, so the base is just the x. So if I was writing it in expanded form, I would have the negative 2 out front, and then I'd have x multiplied by itself 4 times, right? But on the next one, if I have negative and then I have 2x raised to the 4th, right, I'm going to have a negative out front. My base is my entire 2x. So this is like a negative 1 out front, and then 2x times 2x times 2x times 2x. Okay, and then the next one, do you guys see the base for this one? Yeah, it's negative 2x, exactly. So it's going to be negative 2x times negative 2x times negative 2x times negative 2x. Oops. And all of these actually have different values. So if I went ahead and multiplied it all out, like simplified, the first one would be negative 2 times x times x times x times x. That's the one that is negative 2x to the fourth. This one would be 2x times 2x times 2x times 2x would be 16x to the fourth, but then I have the negative out front, right? So this one is going to be negative 16x to the fourth. And how about the last one? What do we think that one's going to be? Negative 2 times negative 2 times negative 2 times negative 2. Positive 16, yep, and then x to the fourth. So see how they're all different. So it matters what's being raised to a power. All right, so this next part is definitely review, I think, of Algebra 1. So it says write each expression using exponents, so go ahead and do it along with me. So the first one should be 3 to the 4. The next one should be 5 to the 3. X to the 5th. You guys all feel pretty good about these? Then I'm going to have 2 squared times 5 cubed. So I don't combine that and say like 10 to the 6 or anything like that. So the 2 and 5 can't be multiplied. And then this one's going to be negative 3 in parentheses squared times 2 cubed. All right. So this next one says write each number in expanded form and then simplify as much as possible. So now we're going to do the opposite. So we're going to write it out. So this first one is going to be 2 times 2 times 2 times 2 times 2. And then we'll go ahead and combine. So if I have 2 times 2 times 2 times 2 times 2, so 5 2's, do you guys know what that is? Yeah, 32. And this next one's going to be negative 2 times itself 3 times. So we're going to get negative 8. And then this one's a little bit different, so don't be tripped up. A lot of people mess this up. And I have a lot of people that come to me and they're like, my calculator told me the wrong answer. I'm like, no, your calculator is telling you what you input. So if you want to do negative 2 times itself 4 times on your calculator, you have to put parentheses, right? If you wanted negative 2 multiplied by itself 4 times. This is not what that is. So C is different. So it's a negative out front, right? So we'll put negative 1 and then times 4 of the 2's. So this answer should be negative 16. But if I had a negative 2 times itself 4 times, it would be positive 16. All right, so the next one should be 1/2 x times 1/2 x times 1/2 x times 1/2 x. So if you want to, you can always rearrange it so all the numbers are out front and all the x's are on the end. So if you wanted to, you don't have to do this. But you could write 1/2 times 1/2 times 1/2 times 1/2. And then times x times x times x times x. So we get 1 over 16 x to the 4th, right? Because 1/2 times itself 4 times is 1 over 16. It's not 2. That would be adding, right? 1/2 plus itself. All right, feeling pretty good about this still? So negative 1/3 x times negative 1/3 x. We'd have negative 1/3 times negative 1/3 multiplied across the top and bottom. We get positive 1 over 9 x squared. All right, and then the next one, same idea. So I'd have negative 2, and then I'd have 1, 2, 3 a's, 1 b, negative 5, 1 a, 4 b's. So if I combine my numbers, I have negative 2 times negative 5 gives me positive 10. And then I have 1, 2, 3, 4 a's. So I'm going to have 10 and then a to the 4th. And then I have a total of 5 b's, so b to the 5th. Okay. Do we feel good about this? Thumbs up? Everybody feels good? All right. It's going to get harder in just a little bit. All right, so we have all these different properties, and I'm sure that you guys all remember these, or have seen these properties, but I don't know if all of you like remember every single one of these. So the first one is the product of powers property. So it says to multiply powers with the same base, we add the exponents. So if we have like 2 to the 5th times 2 to the 3rd, think about it in the expanded form. We'd have 2 times 2 times 2 times, we'd have it 5 times, right? And then we have another 3 times, so we get a total of how many 2's? To 8. So 2 to the 8. So just like with x's, if I have x to the 5th times x to the 15th, I would get x to the 20th. So we're thinking about expanded form. So quotient of power. So let's say I have x to the 5th over x to the 2. All right, in order to do this, we subtract the exponents. So what we think of this as is 5x's on top, 2x's on the bottom. And just like with fractions, you know, if I had like 16 over 10, I think of it as 2 times 8 over 2 times 5, and I reduce out anything in common on the top and the bottom. The 2 and 2 reduce out. That's what I'm doing on things like this. So if I have 2x's on the bottom and 5 on the top, then I'm going to cancel 2 on the top and the bottom. So I end up getting x cubed. That is typically how I teach my students to think about this. Think about it in expanded form. Where are they left? Because it gets a little bit confusing when we have the other direction. So if I had x to the 4th over x to the 8th, let's say. Yeah, if we do the subtraction thing, it's x to the negative 4, and then it's confusing. It's like, wait, do I put the negative 4 on the bottom, on the top? Where do I put this? So what I always tell people to do is think about expanded form. If you have 4x's on top and 8 on the bottom, I should have chosen a smaller number, like that, then we can reduce out 4 on the top and 4 on the bottom. And when we reduce a fraction like that, what's left on the top? 1, right? So this ends up being 1 over x to the 4th. Does that make sense? So that's how we're going to be doing that. Think of it in expanded form and then reduce out. We don't have to write it out every single time. All right, so powers of a power. So if I have x to the 5th, well, that's okay. And then I square it. Right, what that is, it means x to the 5th times x to the 5th, right? So if it was in expanded form then, I would have 5x's lined up. I'd have another 5x's lined up, so I'd have a total of how many x's? 10. Okay, so what we do from the beginning, instead of writing it separately, is we could just multiply the 5 and the 2. Okay, so when we multiply 5 and 2, that's how we're getting 10. Okay, and then a power of a product. So if I have x squared y to the 5th, and then I raise it to the 3, that 3 goes into both pieces. So I'm going to have x to the 6th, and I'm going to have y to the 15th. Kind of like the distributive property. That's what everybody always says every year when I do this. It's like the distributive property. So it goes to both of those pieces. And why is that? Because if I had it to the 3rd, I would multiply that whole thing by itself 3 times, and then I could think about expanding it, right? All right, and then the power of a quotient, same idea. If I have x to the 8th over y to the 3rd, and I square it, what do you guys think we'd get? X to the 16, y to the 6. Okay. Still okay? All right, so let's practice. So you have a couple examples, so go ahead and try them along with me. Make sure that you're getting these. So I have 5 to the 3 times 5 to the 4. So think about it in expanded form. I'd have 5 times 5 times 5, and then I'd have another 5 times 5 times 5 times 5. So how many 5s do we have? 7, exactly. So we have 5 to the 7. The next one, we could rearrange all of the terms. I have a 5 out front. I'd have x cubed and another x cubed, so I have x to the 6th and then y to the 4th. Okay, so these are the types of things that you definitely did in Algebra 1. Okay, so Algebra 2 is always a little bit of a step up. We review what we did, and then we do a little bit harder. So this next one, if I had x cubed y to the 7th over x squared, imagine the x's on top and bottom. We have 3 x's on top. We have 2 x's on bottom. So 2 are canceling on the top and the bottom. Whoops. So we're going to be left with an x on top and a y to the 7th. And then I could write a 1 on the bottom, but I'm just going to leave it. So I could say xy to the 7th all over 1, or just xy to the 7th. Okay. Still feeling good about this? What about the next one? Anybody know what this one is? Yeah, x to the 8th times y to the 12th. Perfect. Okay, so the next one involves something to the 4th. You could raise it to the 4th, like take every single power and raise it to the 4th now. Or you can simplify first and then raise. So I'm going to simplify first. You don't have to do that. It just makes it easier if you have smaller numbers, or if you have lots of big numbers, I guess. So if I have an x and I have an x squared on the bottom, how will those reduce out? You could subtract, but we don't want to do negatives, right? So if I have x on top and I have x squared on the bottom, Becca, what do we get? Exactly. So she says just one x on the bottom, right? Then we still have the y squared, we still have the z on the bottom. And it's still raised to the 4th. So now we raise each thing to the 4th. So we're going to say y to the 8th over x to the 4th, z to the 4th. Okay, and the reason those are to the 4th is because these powers that we had before, the x and the z, are really x to the 1, z to the 1, right? So when we multiply 1 times 4, that's how we're getting the 4. Okay. Do you guys want to try the next one? Just go and try it. See what you get. I would probably simplify first. So when we simplify on the inside, we have a squared on top and we have b on top. So that means it's really just a 1 on the bottom. You don't have to write the 1 though. So if you instead wanted to erase that and just write it like that, that would be totally fine. And then we raise it to the 3, so don't forget that this is b to the 1st power. If you need to put the 1 in, that's fine. So we end up getting a to the 6th, b to the 3. And that's our answer. Okay, so far, I mean, it might be a little bit of a stretch, like remembering every single detail from Algebra 1, but so far I think this is pretty good for you guys, right? Still feeling pretty good? All right, so let's get into some more challenging ones. So the zero exponent property. So it says a non-zero quantity raised to the 0 power is equal to 1. So why is that? Okay, so let's think about one that we know. So if I said x cubed divided by x cubed, right? We said that was x times x times x all over x times x times x. So what does it end up being? 1, right? So this is all equal to 1. However, what if I use the subtraction property? So remember how I said, like, if I had x to the 5th over x squared, I subtract my powers, x to the 5 minus 2. It's x cubed. What if I do that here? I get x to the 3 minus 3, which is x to the 0. So in other words, 1 is equal to x to the 0. So anything to the 0 power is equal to 1. I should be kind of careful saying that, because actually 0 to the 0, we don't know what that is. It's undefined. There's a big debate about it. Is it 0? Is it 1? There's not really a big debate. It's just neither 1. Okay, so 0 to the 0, we don't say it's anything. So if I have something crazy and it's like 3x squared y over 5z to the 5th, all raised to the 0. Yeah, that whole thing is raised to the 0 power, so that whole thing is equal to 1, right? All right, so how about the negative exponent property? So we'll do something similar on this. So what if I had x squared over x to the 5th? If I subtract my powers, 2 minus 5, I get x to the negative 3. But that's not the way I was telling you to write it. I was saying it's easier to think about it in expanded form. If you have 2 x's on top and you have 5 x's on the bottom, when you cancel, how many x's are going to be left and where will they be left? You'll have 3 on the bottom, right? So really, this is all equal to 1 over x cubed. Does that make sense? So 1 over x cubed is the same as x to the negative 3. So if you have x to any negative power, just do 1 over and then put the positive exponent. Yeah. I like positive exponents in the end. So, yeah. All right, so what if you have a fraction? So it says a non-zero base raised to a negative exponent is equal to the reciprocal of the base. So if I had something like 2/3 to the negative 4, that's kind of weird. We don't want to do like 1 over a fraction, right? That would be really strange. So instead what we do is we flip the whole base and write it as 3 over 2 and then raise it to the positive 4. Okay, so it says fill in the following table and answer the questions on the right. So 2 cubed is 8, 2 squared is 4, 2 to the first is 2. Do you see the pattern? 8, 4, 2. So 2 to the 0 is 1. 2 to the negative 1? Yeah, it's 1 over 2. 1 over 2 to the first, right? The next one is 1 over 2 squared, so 1 over 4. Keep dividing by 2, 1/8, and 1 over 16. So that's why 2 to the negative 4 is 1 over, right? That whole thing is 1 over 2 to the 4th, which is 1 over 16. It follows that pattern. So do negative exponents mean that the number is negative? So if I had 2 to the negative 4, was my output, was it negative? No, I had a positive number in the end, so no. It is just the reciprocal. I don't know how to say this, but I'll say of the positive exponent. So if I raise the whole thing to a positive number, it's a reciprocal. So what does any number raise to the 0 power? 1. And then what do you notice about 2 to the 3 and 2 to the negative 3? They're reciprocals, exactly. Okay, so this is where it starts to get to be a challenge. Okay, and this is where I think it's a lot different than Algebra 1, unless you had a really good Algebra 1 teacher that was really showing you this stuff. All right. So if I have 4 to the negative 3, so we just said 4 to the negative 3 is 1 over 4 to the 3. 4 to the 3, 4 times 4 is 16. 16 times 4 is 64. So this whole thing is 1 over 64. 16 times, so 4 times 4 is 16. 16 times 4 is 64. As a math teacher, I know lots of squares and cubes. All right, so x to the negative 2. So I get 1 over x to the positive 2, right? But if I already have a fraction for my base, it's not easy to do a 1 over a fraction. So you could do it this way where you say 1 over 1/2 to the positive 2. That's kind of gross. It takes a long time. It would work. You'd get 1 over 1/4. 1 divided by 1/4 is 1 times 4 over 1, which gets you 4. But that's a lot of work. Okay, so the easiest way to do these ones is to flip the base. So I'm going to write it as 2 over 1 raised to the positive 2. Well, 2 over 1 is 2, so 2 squared is 4. Much faster, right? So if you already have a fraction for your base, just flip the whole fraction. How about number 4? Do we all know that one? Yeah, it's all raised to the 0. What about number 5? Ah, be careful. Part of it, this part's 1, right? So we have 2x times 1, which is going to be 2x. I tricked you. All right, so the next part we have raised to the negative 3. So it's already a fraction, so let's just flip the base. So it's going to be y over 2x raised to the positive 3. Okay, so everybody always gets, like, they would get the y cubed and the x cubed. For some reason, I would say about 25% of my class every single year forgets the 2. So what do we think the 2 is going to be? 2 to the 3, which becomes 8, right? So don't forget about the 2. The 2 is going to be cubed as well. Right, because what is it? It's y over 2x times itself 3 times, so we still have that 2 times 2 times 2 there. So always think in expanded form if needed. All right, so the next one, we're going to flip the base. So we're going to get b squared over 3ab, and we're going to raise to the positive 2. And then from here, you can do lots of things. You can simplify on the inside and then square, or you can square everything and then simplify. It doesn't matter. I tend to simplify first, just in case we have some messy numbers. Okay, so how about the b squared and the b? Yeah, so b on the bottom, b on the top go away, so I get b over 3a, and then I square it. So when I do b over 3a, and then squared, it's b over 3a times b over 3a, so I get b squared over 9a squared. That's my answer. All right. You do. The 3 times 3 is the 9. Yeah, that makes sense. All right, so what if we have lots of weird things? Like this one has negatives inside the problem. Okay, that's kind of weird. Okay, so you can do the subtraction rule if you want to. Here's my trick. Okay, this will make it a lot easier. Do you guys get a little overwhelmed when you see like negatives in the top, negatives in the bottom? It's a little overwhelming. So the way to make this easier is to move anything that has a negative exponent to the opposite location and make it positive. Okay, so anything with negative exponent moves to opposite side and becomes positive. So I can show you why that's true. It takes a while. It's kind of like that one that I did, that was like 1/4 raised to the -2 or something like that. But basically anything that has a negative exponent would end up being 1/x cubed. Well, 1/x cubed puts the x cubed in the bottom. Okay, so this x to the -3 is going to go to the bottom as x cubed. You leave the 5, yep, because it's not being raised to a negative exponent, right? And then do you see anything else that has a negative exponent? Y to the -2, that's going to move up and become a positive. So we're going to rewrite. So I'm going to keep my 5 where it is. I'm going to keep the x to the 5th where it is. I'm going to keep the y cubed where it is. I keep my 15 and my x to the 0 where they are. And what did I move? I moved that x to the -3 as an x cubed to the bottom, right? It was on the top, x to the -3, and I put it on the bottom as x cubed. And then I can move that y to the -2, I can move that to the top as y to the +2. Okay? It's still all raised to the +2, just like it was before. But does it look easier now? Yeah, it looks a lot easier. Yeah. Yep, so we're combining. So how about the 5 and the 15? Let's start there. Yeah, they reduce out just like normal, 1/3. They're just like a fraction. Don't subtract don't subtract them or anything, thinking, oh wait, these are like exponents. They're not. They're just regular numbers. 5/15 is 1/3. All right, then we look at our x's. So I have x to the 5th. What about that x to the 0? That's all 1, so I'm just going to cross that out. So I have x to the 5th on top, and I have x cubed on the bottom. Imagine 5 x's on top, 3 x's on bottom. How many would I have left, and where would they be? 2 on the top, right? So I'm going to have my 1, and I'm going to have my 3 from before, and then I'm going to have x squared on top. How about the y's? How many will I have on top? 5, y to the 5th. And then I'm going to raise it all to the 2. So square everything inside. So 1 squared is just 1, x squared squared is x to the 4th, y to the 5th squared is y to the 10th, and then don't forget about that little 3 down there. 9, exactly. All right, and then number 9, if you can do number 9, you can do all of them. So number 9, I have 36, a to the -6, b to the -5, c to the 3, all over 45, a to the -5, b to the -3, all raised to the -2. So let's work on the inside first, and then we'll deal with the -2 at the end. What do you think the -2 is going to do? Flip everything on the inside and then raise it to the +2, right? So we'll deal with that at the end. So how about our 36 and 45? Do they reduce out? If I had 36 over 45, would you leave that as your fraction answer? No, they're divisible by 9, right? So let's divide by 9. So we get 4 and 5. Maybe I should move things first. All right, so now we're going to move. So the a to the -6, the b to the -5, the a to the -5, and the b to the -3 are all going to move. There's a lot of moving going on in this one. All right, so we're going to get a to the 6th on the bottom, b to the 5 on the bottom. What about that c cubed? It's still on top, right? And that a to the -5th that was on the bottom is now a to the 5th on top, and b to the -3 that was on bottom, now b to the 3 on top, right? And still raised to -2. Yeah? No, like I just put those where they were, but they could be wherever. Yeah. Just as long as they're on the top and the bottom. It doesn't matter where they're lined up. All right, so I'm going to have 4, and I'm going to have my 5 still. How about the A's? Looking only at the A's, I have 5 on top, 6 on the bottom. So if I reduce them out, I'm reducing out 5 on the top and the bottom. I have 1 on the bottom. And then my B's, how many B's do I have, and where are they? B squared on the bottom. Did you guys see that? 3 on top, 5 on bottom. 2 left on bottom. And then my C cubed stays where it is, raised to the -2. So we're going to flip the base. And we're going to raise to +2 now. So when I flip the whole base, I'm going to write my 5ab squared all over 4c cubed, all raised to the now to the +2, right? I changed my power. Instead of negative, I now have positive because I flipped everything inside. Took the reciprocal. So final step, raise everything to the 2. So I'm going to have 5 to the 2 is 25, a squared, b to the 4th, all over 16, c to the 6th. And that is my answer. Yeah? Mm-hmm.
So when you were doing it last and then you were distributing the 2 into the b over 3a, why did you get 9a on the bottom? Wouldn't it be
because, well, no, because from here I would think of it as b over 3a times b over 3a. Does that make sense? Yeah. So 3 times 3, yeah. Yeah, a lot of people will do 5 squared and they'll write 10 because they're so used to doing the exponents by multiplying, so be careful with things like that. So the numbers are just like normal. All right, so we're going to stop here. I'm going to pass out your homework.